Hey, my name is Koen. I'm from the KULeuven University in Belgium. Together with my colleague Eric de Meester, I'm going to present our proposal for the upcoming year, what we're going to do with the PR2. I'm from the Department of Mechanical Engineering, and we're the founders of Oracos. How many of you already use the KDL library at the moment? I think it's well known. KDL is one part, a sub-library of the Oracos project. Another one is the BFL, it's the Bayesian filter library. And the third one is the real-time toolkit, that is the main topic of our proposal. So what is our proposal about? We have the real-time toolkit integrating into ROS. We have an iTask framework, which is a constraint-based framework to specify tasks which we are going to integrate into ROS. We're going to integrate Blender into ROS, and of course many more, like providing demos and backfiles. So the first is the real-time toolkit. What is our vision on the combination of Oracos and ROS? We see that the real-time toolkit is ideal to provide the management of nodes, to provide service management, state machine supervision. We currently use ROS as a development framework. It provides a good middleware to connect multiple components or nodes. And we like the fact that ROS already has a large amount of stacks that can interconnect and that also are capable to interconnect to our Oracos framework. Actually, Oracos and ROS really are very similar. They have the same semantic mapping. What is ports is called topics in ROS. What we call it services in ROS are called operations in Oracos. And parameters and properties are all the same. We want it to work like a plugin, that the user has no overhead, that the ROS data types are also available in Oracos, and that it's created for the user automatically. So how do we see it? For a node and a component, it's very easy. The topic can direct connect to the data flow of the component. How do we see it for the services and the operations? Well, actually, we'll generate an extra Oracos component that will be created out of the server file that fetches the service request and will cast it to an operation in Oracos. For properties, we'll do the same. We'll have an automatically generated property component that has a full duplex communication. So if you add a property which can be dynamically added as the same as in ROS, it will add it on a parameter server and vice versa. If something is added on a parameter server, it will be added in the Oracos framework. Then the second big part of our proposal is iTask. What is iTask? iTask is a way of specifying tasks that are complex. It allows you to define motions in different feature spaces. It can over geometrical sensor spaces like camera, laser scan, and you can define tasks only based on constraints over all those feature spaces. What we're going to do, we're going to include the iTask into ROS, that is freely available, and we're going to illustrate the power of it by doing some demos with the PR2. What is iTask? I've got a video with me to demonstrate the power of it. It's actually, in the video, you see two 6 degrees of freedom robotic arms which are doing a task, and the task contains many things. So we have two robots, an object which is unknown, and a lot of sensors. It's the task of robot 2 to sense what the object is like, and robot 1 is handling it. So we have a system that contains 12 degrees of freedom, but for following the contours of the object, it would only need 2 degrees of freedom. So we have some degrees of freedom left that we can specify other tasks while doing the sensing. So it also has a camera mounted on one of the two robots, and the camera actually follows the closest person, keeping it in the image, and keeping the person in the image is also 2 or 3 degrees of freedom of the 12 degrees of freedom that we have. So we still have some degrees of freedom left. What do we do with it? Actually, if the person comes closer, you'll notice that the two robots go back, avoiding collision with the human, but still they don't stop their task. They'll continue. You can also have the case that you'll have more constraints defined than your system allows it. In that case, we can implement priorities in which the constraints will be taken into account. Okay. Actually, the way that we define those tasks is independent of the robotics platform that we use. The solver will take into account in the end what platform is used and try to solve it as optimal as possible. Yeah. Then the third part is we want to include Blender into ROS. What is Blender? Blender is a free and open source software package. It's used to create 3D content. It's mainly used by computer animators, but it also can be easily used for robotics. The advantage is, because I got a comment from many out here, that yeah, actually that's what Gazebo is providing, or that's what Arvis is providing. But Blender allows you to do both simulation and visualization in one framework. It has a large community. Computer animators are a much larger community at the moment. It provides photorealistic rendering, and we use it as our virtual lab to test algorithms before testing them on the real robots. Because you can easily change all the environments. If you have a virtual camera, you want to test how reliable your algorithm is. You want to be able to test different textures, different lighting, and so on. And it's very, very easy to do it. It also has a physics engine. So how are we planning to do that? We're working together with the people from LAS in Toulouse and Onera. And we're creating what we call Morse. And it's based on the Blender game engine that we interface of middleware independent to your algorithm. Its first official release will be upcoming month. What did we actually do already with Blender? We interfaced it. We interfaced it to Corba, ROS, YARP, and regular TCP UDP streams. We have the PR2 model in there, and we are currently implementing the kinematics for it. What are we going to do more? Because we're using Blender and because it's easy to draw models and other things in Blender, we're going to try to improve the Collada support for ROS, meaning conversion to URDF, conversion to KDL, and so on. We will also be implementing a multi-target tracking and localization algorithm. Now, of course, we need to show off all those implementations. It's just software. We need some demos. One of the demos that we're going to do is, as you can see it on the picture, which was provided by Ken, we're going to walk in a crowded environment with the PR2 following a person, and basically do a moving task. So we will try it with different objects, and for all this we'll use the multi-target tracking and localization algorithm, and we'll show that it's possible to define such a task with the iTask framework. We'll have some more demos, which I'll gladly explain. If there are any questions, you can always come by later on.